Okay, all the laws of exponents we looked at in the previous two videos have the same base everywhere. If you look at the summary on the right-hand side, every one of them has the base as a. What we want to look at now is what if our base is slightly more complicated. So I'm going to look at what if our base is actually a product. Okay, so if we have 2 times 3, the quantity raised to the 5th power, then that means we're going to multiply 2 times 3 times itself 5 times. That's what the 5th power means. I should probably move my hand so it's actually on the screen. That would help. Okay, so 2 times 3 to the 5th power would mean 2 times 3. 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 Okay, now I'm going to combine some of our rules of exponents that we've talked, rules of multiplication that we've talked about. First of all, the associative law says you can put the parentheses wherever you want, so we could erase these parentheses and put them somewhere else if we wanted to. The commutative law says that you can switch the order of two numbers, so if I wanted to, I could switch this 3 and this 2, for instance, or I could shuffle all of the orders and put all of the 2's at the front and all of the 3's at the back. I'm going to do that. So I'm going to rewrite this as all the 2's up front. There are 1, 2, 3, 4, 5 2's. There are also 5 3's. And so what we end up with is 2 multiplied by itself 5 times, which would be 2 to the 5th. 3 multiplied by itself 5 times, which would be 3 to the 5th. And I think that's good. That tells us what we're supposed to do if we have a product raised to the power. Apparently it's each part of the product is both can be raised to that power. So let me write that down. If we have something like an a times a b raised to a power, that's going to do the same as a to the n times b to the n. And you can think about this as kind of being like a distributive property for exponents and multiplication. The same doesn't work for exponents and addition, but exponents and multiplication interact in the same way that multiplication and addition do. You do have a distributive property where a product raised to the power, you take each part of the product raised to that same power. Okay, I have one more thing I want to look at, which is what if instead of a product raised to a power, we had a quotient raised to a power? So let's try 2/5 cubed. Okay, 2/5 cubed would mean 2/5 times itself 3 times. So 2/5 times 2/5 times 2/5. But our rule for multiplying fractions says you multiply the tops and you multiply the bottoms. So 2, 2, 2 in the numerator, we would multiply those. 5 times 5 times 5 in the denominator. And again, you should be seeing the theme. Those look like repeated multiplications. Those are repeated multiplications. That's going to be an exponent. So the numerator seems to be 2 cubed. The denominator seems to be 5 cubed. Okay, and so again, we should be able to come up with a rule for how exponents are supposed to work. Apparently, if we have a quotient raised to a power, we're going to raise each part, numerator and denominator, to that power. So we get our last rule of exponents. Quotient raised to power, you raise the numerator and the denominator to that power.